So the next aspect of covalent theory. I said there are three covalent theory. I'm going to explain. We have Vesper theory, we have valence orbital theory, and we have molecular orbital theory. So in my previous video now, I've explained the Vesper theory, which we use to predict the shape and geometry of a molecule. So the next theory now is what? Valence orbital theory, which is what? VOT. What is valence orbital theory? Is a quantum mechanics approach that we use to describe the overlapping of orbitals in a molecule. That is what? This is a quantum mechanics approach that use to describe the overlapping of orbital in a molecule. So the valence orbital theory is just deal with what is describe the way the orbital will overlap with each what with each other. Where Vesper theory describe the shape and geometry of molecule. So the valence orbital theory, this theory just based on what how orbitals what will overlap with each other to form a covalent what bond. You can also what it explain the formation of covalent covalent bond in a molecule. It explains what covalent bond in a molecule. And this valence orbital theory is just comprised of two rules. If you look at what the first part theory, I gave you 5 rules. So this one comprised of what? Of 2 rules. The first rule is what? We call it what? It explains that before two orbitals can overlap with each other, they must have the same line of what? Of symmetry. The second rule is what? Is right energy rule. It says that what? Orbitals that overlap with each other must have the same energy what? Energy level. That is what? The rules under what? Valence orbital theory. The first one is states that one states that what? States that what? Before orbital can before any orbital can overlap with each other. They must have the same line of symmetry. Let us look at this statement. If we have s orbital, now we have s what? Orbital, recall from atomic theory, atomic orbitals. Now we have quantum number, principal azimuthal. Is the azimuthal quantum number that explains the shape of orbital, abi? The azimuthal tell us that what? S what? Orbital have spherical shape, abi? The same azimuthal tell us that what? PS orbital have this shape, where what? Py orbital have this shape number, where pz has slight number. So if you combine these three together, we have what? This kind of what? This is what? P what? Orbital. But so this P orbital contain what? Py, pz, and P what? Px. Abi? Go and check my video under atomic what? Orbitals. So this is s orbital, this is ps, this is the py, this is the pz. We apply it here now. So this x now, x what? Orbital. This s or what? Orbital. If this s orbital want to overlap with another what? X. Let's check the line of symmetry. Problem of line of symmetry. If you are talking about line of what? Line of symmetry is a line that divides a body into two equal parts. Take for this sp orbital, the line that divides into two equal parts, call it what? Line of symmetry. We can divide this s orbital into two equal parts in this form. This line is line of symmetry. If you like, you can divide s orbital into two equal parts in this form. Also line of symmetry. If I like, I can write it into the two equal parts in this form. Line of symmetry, or in this form. So that is what? The s orbital is spherical, abi? You can divide s orbital into two equal parts in any direction. But to divide this into two equal parts, this is the line of symmetry for what? For x. For y, this is the line of symmetry for what? For y. For z, this is the line of symmetry for what? For z. So this do now say that what? Before any orbital can overlap, their line of symmetry must what? Must the same. Check this side now. For this s orbital and ps, they have the same line of symmetry. S orbital and the py, they have the line of symmetry. S orbital and pz have the same line of symmetry. S orbital and what? Yes, py, pz. So the s orbital can overlap with what? With any orbitals. So for this now, let's check it here. The line of symmetry for this one, it will be what? Go like this. Two of them have the same line of symmetry, equal parts. Like this, equal. Like this, equal. Can say that what? The two orbitals, they can divide into two equal parts with any direction. Therefore, so the s orbital can overlap with what? Another what? Another s what? S orbital. So this overlapping is what? Is allowed. That is, we can have what? S, S, S orbital over what? Overlap. But in case of what? S orbital, we have S what? Orbital plus Px orbital. Are they have the same line of symmetry? No? Yes? Let's check. The line of symmetry of Px is what? Is this. That's the two copper. If you continue like this, the line also divide what? S into two equal parts. Therefore, this x and what? And px, px can what? Can overlap. So we can have overlapping. This overlap is what? It can exist. We call it what? X px over what? Overlap. So let's look at what? Another one. This x can also overlap. So this x can also overlap with what? With p. This is the p what? Py orbi what? Orbital. This one is what? S what? Orbital. So when the two, let us check if they can overlap. Divide this into line of symmetry for this one is what? Is this. For this one is also what? Is this. You can see that what? They have the same line of what? Of symmetry. Therefore, they can also what? Over what? Overlap. So you now have what? S orbital overlap with what? This. So this overlapping, we call it what? SPY over what? Overlap. And the next one is this same S can also overlap with P what? PZ, which is what? Slight. This is the P what? Z over what? Orbital. This S what? Orbital. Check the what? The line of symmetry for DZ is light. If you bend it like this again, it's also divide S into what? Into two equal parts. Since they have what? The line of symmetry, so we can also have what? It in this form. S orbital overlap slightly with what? PZ. This is called PZ over what? No, we call it X PZ over lap. Good. So this overlapping can what? This overlapping can exist, can exist, can exist, can exist because they have the same line of symmetry. And we can also have what? P. If we have px orbital plus another p what? Ps. Px or what? Orbital. This overlapping can also exist. Why? Check their what? Line of symmetry. If we continue like this now, we can see that they have the same line of symmetry. The same line divided into two equal what? Parts. So this, it can give us what? This kind of structure. So this bond here, we call it what? Px, Ps over what? overlap. So, and we can also have what? Py, P what? Py orbital plus another what? P what? Y orbital. Check the overlapping here. So the two of them can what? Can overlap in this form because they have the same line of symmetry. And this kind of overlapping, we call it what? Py over overlapping is also possible. And the last one, you can have pz with pz. This is the pz what? Orbital. We have pz what? Orbital. So the two of them have what? This, the same line of symmetry. So if you have what? This in this form, they can overlap. This overlapping, we call it pz overlap. So we have how many possible way of overlapping? This. So we have what? This is the first possible way. Second, third, fourth, fifth, sixth, seventh. According to the what? The valence orbital theory, we have 7 possible ways in which the what? The orbitals can what? Can overlap. But we have what? Let me impossible overlapping. Civil over what? Overlapping. What are the impossible overlapping? Let's check it. In case of what? We have PS orbital. You now said you want to overlap it with what? PY orbi what? Orbital. Look at line of symmetry for what? For X. Is this line of symmetry for Y? Is this, are they the same? This one is horizontal line of symmetry, this one is what? Vertical line of symmetry. So if you now say what? They overlap in this form. So this is what? It can never possible. It can never what? Possible. Or if you say we have what? P, we have it in this form, overlap with this. This is the P what? PY and PZ. The line of symmetry for this PY is what? Is this. Is this. You can see that what? Their line of symmetry are not what? Are not the same. One bend, one straight. So you are now have what? This to overlap with what? With this. It is what? Impossible over what? Overlapping. So the PS can overlap with PS, PY with PY, PZ overlap with PZ, P31, or any one of them can overlap with what? With X. That is what the valence orbital force theory say. The second theory It says that two orbitals that overlap with each other must have the same energy level. Now what? Two orbitals that overlap with what? With each other must have what? The same energy what? Energy level. So that is what? If x, one s orbital want to overlap, it cannot overlap with what? With two what? Two s what? Orbital. So this is can never be what? Possible. Two s orbital can overlap with what? With two s what? Orbital. This one is what is possible. Or two s orbital plus two p orbital. They must have the same what? Energy what? Energy level. So that is all about what? Valence orbital what? Theory. Then types of covalent bond. There are two types of covalent bond. The first one, you call it what? Stigma bond. The second one, you call it what? Pi bond. Sigma bond is this. This is what? The pi bond. So let's take it one after the what? Other. What is sigma bond? Yeah, sigma what? Bond. This sigma bond, this is the what? The end to end collision. End to end what? Collision. Or you can also call it what? Head on collision of two atomic orbiter. Or we can also call it what? End to end overlapping or head on overlapping. In other words, the end to end collision, this collision can use what? Over what? Overlapping. Over what? Overlapping. You can use to repeat it here. So what is sigma bond? See, this is sigma bond. Look at these two marker. This is what? Blue marker. This one is red. So if these two marker want to what? Overlap, and they overlap like this, end to end overlapping. When they overlap with two ends, this is what we call what? Sigma bond. End to end overlapping or linear over what? Overlapping. And this also called what? Axial over what? Overlapping. When two atoms overlap in linear form, in axial form, or in end-to-end overlapping or head-on overlapping, we call it what? Sigma bond. And this bond is very strong compared to the what? Pi bond. What is pi bond? Pi bond is a bond that exists between two what? Orbitals. That is vertically what? Like this. When two orbitals are overlapped in this form, in this what? In this form, this vertical form, this kind of overlapping, we call it what? Pi bond. But this kind of overlapping, end to end, we call it what? Sigma bond. So the sigma bond is what? End to end overlapping or head on overlapping or linear overlapping between what? Between two orbitals. And the sigma bond can exist in three forms. In three forms of overlapping. The first one is what? S orbital overlap with another what? S orbital overlap with another what? S what? Orbital. See, you can see that what? This overlap here, this is over what? Overlapping here. You call it what? S over what? Overlap. And it will later form a sigma molecule. So the compound that's formed here, we call it what? Sig what? Sigma mole what? Molecule. And this bond here, we call it sigma bond. Let me overlapping. We call it what? Sig what? Sigma what? Bond. The molecule form is sigma what? Molecule. So let us look at another one. The s orbital can also, sigma can also form in this form. S orbital plus ps orbital. And they overlap in this form. D is x, D is what? P. The bond here is what? Sigma bond. And it will later form a what? A molecule. And this molecule form here, you call it what? Stig what? Sigma molecule. And the third one will be px plus another px orbital. So it will give you what? ps the molecule form here, it will be this molecule. This is what? Stigma molecule. The bond we have here is sigma what? Sigma bond. These are the three possible ways of existing of what? Of sigma bond. The last bond now is what? Pi bond. Pi what? Pi bond. What is pi bond? I said it. Pi bond is a bond that exists, is the vertical overlapping between what? Two orbitals. When two orbitals are overlapped vertically, we have what? Pi bond, and the pi bond is weak bond. The sigma bond is stronger than what? The pi bond. So, and there are two possible ways of formation of pi bond. Let us look at it. The first one is this. If we have px to overlap with what? Sorry, if we have p what? Py to overlap with what? Py. So the overlapping, we have it in this form. This is overlapping. And after this overlapping, we have our molecule to be in this. P will be the molecule over what? Overlapping. When they overlap together, and the bond here is what? Is pi bond. And this will be what? pi molecule. The second overlapping for pi, we can have pz plus pz, pz, pz. When they overlap, we have them in this form, in this form. So the bond here is what? P is pi what? Pi bond, and their molecule form, it will be in this form. Their molecule form, it will be in this what? In this form. This is called what? Pi bond molecule. So you can now see that what? The pi bond can be formed between what? PS, PY, PY, PZ, P what? PZ, and there is a weak bond. But the sigma bond can be formed in what? In end to end over what? Overlapping. So that is all about valence what? Bond what? Theory. Under this valence bond theory, we have sigma bond, we have sigma and pi bond, and we also have hybrid what? Hybridization. So we have explained what? The valence bond theory, then the type of covalent bond. Now I said what? This valence bond theory explains formation of covalent of what? Covalent bond. So which how covalent bond is formed through pi and what? And sigma bond. The next thing that we are going to treat now is what is hybridization.